All right, before we start 9.2 day 1, let's get through these warm-ups. So for each equation, find the value of y when x equals -2. How do we go about doing that? Ryan? Yep. So y is by itself, but we actually want to get a number for y. And they tell us that x is going to equal -2. So what should we do with that? Good. So it sounds like what you're doing is plugging in that -2 for x. Another word for plugging in would be substituting. That's the premise of this method, is plugging something in for a variable. All right, so Ryan said the first thing we do is multiply. A negative times a negative is a positive 14. And then we have to take 14 plus 2. We get y equals, anybody? 16. And that would be our answer on that one. All right, on number 2, our step is going to be the same. Okay, we can start off by substituting right away. What am I substituting in for? Keon? X. I'm still trying to find y, but they already told me x. So I just have to figure out what y is now. So we can start off by multiplying. The 3 times -2 gives me -6. And how am I going to get y alone now, Keon? Add 6 to both sides. So go back to your rules for solving equations to get y by itself. So this time y equals 7. 1 plus 6 would give us 7. All right, on the last problem, we're doing the same thing. We're plugging in for x, solving for y. What do these parentheses mean? They're grouping two things together, but then once I get whatever's in that group, what am I going to have to do? Keon? Multiply. So remember, parentheses also tell us when to multiply. So let's plug in -2 for the x. All right, what is -2 plus 1? Those are grouped in parentheses, so that's what I should do first. Somebody else, we need more hands. Natalie? -1. So you can leave that -1 in parentheses if you want to. You don't have to. But definitely the y minus 4 is still in parentheses. What could we do next? We technically have a couple options. Surely somebody other than Keon can tell me what to do when we have a number outside parentheses. Ellie? One of our options is to divide both sides by -1. Our other option is to distribute. I don't care which one you do, you should end up with the same answer in the end. Ellie said divide by -1, so we'll stick with that. I'm going to make a little space over here to finish solving it. When I divide the left side by -1, those -1s just cancel each other out. So I'm left with y minus 4. +3 divided by -1 is -3. Who can tell me my last step to get y alone? Add 4. I would agree with that. What is -3 plus 4? A +1. The graphing method for solving systems of linear equations is not as useful when the coordinates of the intersection point are hard to find, such as they are not on the grid line or they are fractions. Therefore, we will learn a different method called the substitution method. All right, so before we get into our official examples, before we get into our harder examples or the official examples, we'll do this as kind of like a secondary warm-up. These are two equations, so this is a system of two equations. Last week we would have graphed both of these, identified M and B, figured out where they intersected, all of that fun stuff. Today, we are not going to use a graph to solve it. Instead, the first equation tells us x equals 1. So much like we did in the warm-ups, we are going to substitute that 1 in for the x in the other equation. So we would write 2 parentheses 1 minus y equals 7. And now we're just solving this, just like we did in the warm-ups. What's 2 times 1? 2. Who can tell me how to continue solving this? May? Subtract 2 on both sides. I'm going to continue the problem up here. That leaves me with negative y equals 7 minus 2 is 5, but I don't want negative y, I want a positive y. So what happens? Ryan?
Don't you divide by 1?
We divide by a negative 1 to make that a positive y, which makes the 5 negative. All right, so you'll notice at the bottom of this slide it has answer, and it's got it set up for us to write an ordered pair. What should go in the first spot? 1. That's what we used for x. They told us x equals 1. So 1 is the x coordinate. What about the y coordinate? Negative 5. That's what we found y to be. This is essentially the same kind of process we're going to use for the substitution method. It just won't always be quite this straightforward. All right, this one is a little bit different. You'll notice that y is equal to x minus 1. And we have 2x plus 3y equals 2. So now we are not given a single number to plug in, like we've been given on all the other problems so far today. So we have to figure out a different way to solve. Lucky for us, we can still use the substitution method. If y is by itself, we know y equals x minus 1. So here, instead of writing a y after that 3, they wrote a big set of parentheses. And in that set of parentheses, we're going to put the x minus 1. This is what the substitution method is usually going to look like. You're going to be plugging in expressions in for variables instead of just numbers. Okay, we'll practice this many more times, so this is just an introduction to it. So if this is what we have, I'll just rewrite it so there's not quite so much blank space. This time we're now solving for x. That's the variable that's left. Anybody have any ideas on what we should do first? Keon?
Multiply.
What do you mean by multiply? Good. So we have to distribute or multiply that 3 into those parentheses. So the 2x out in front is going to stay 2x. Plus 3 times x is 3x. 3 times negative 1 is negative 3. That's equal to 2. What's the next thing I can do to solve? Somebody else? Jamal?
Add
Wonderful. What does that give us? Very good. 5x minus 3 equals 2. I'll carry it on up over here. All right. We've got 5x minus 3 equals 2. Who can tell me what happens next? This is why I gave you that worksheet for homework over the weekend. Solving equations. May, can you help us out with the next step? Good. We add 3 to both sides. That leaves us with 5x equals 5. Last step, Nevaeh, how would I get x all alone here? We added the 3, so we're over here. 5x equals 5. Divide by 5. Good. So x equals 1. Very good. Okay, so we can fill that in the little answer thing here. The first blank is x, so we could fill a 1 in there. Do we know what the y is yet? Does anybody know what the y is yet? You shouldn't. We haven't found it yet. Okay. But we can go back up to the beginning where they said y equals x minus 1. Now that we know x, we can use that information. So instead of y equals x minus 1, what can I plug in for x? That 1. What is 1 minus 1? 0. So I can then find that y would equal 0. This is a substitution method type problem, just from beginning to end. Now we're going to fill in that box so that you have steps written out to help you do this on your own, and then we'll practice it and practice it and practice it. Oh, they wanted us to try another. Let's go to the steps for now. We might go back to that other one if we've got time. All right. To use this method, solve one of your equations for one of the variables with a coefficient of 1. So what that means is you're getting one variable all by itself in one of the equations. Step 2 is to substitute the value of the variable you solved for into the other equation Step 3 is to solve for the variable. So whatever variable is left, you're going to solve for it. Step 4 is again to substitute the variable back into the other equation. I don't think you need a blank there. To find the other value. Your solution is still an ordered pair. While we're working on number 1, I'm going to take number 2 away so that we've got plenty of room. You will notice that on this problem, and I think on most of your problems today, you will have one equation that already has a variable alone, right? On this first problem, the y in the top equation is already alone. That helps us out. I think tomorrow is when we'll introduce you having to get that by itself. So really, they've done step 1 from our box for us already. They've got one equation with one variable by itself that has a leading coefficient of 1. So now we're going to take that expression that y is equal to and substitute it into the y in the other equation. This first step can sometimes be the most confusing. We're going to take this whole thing and plug it into that other y. So what I like to do is rewrite the second equation, leave a big blank for that variable that I'm plugging into. So negative 6x plus blank equals 5. In that big blank, I'm putting the 3x minus 1. Any questions on what I've done so far? Nothing? Okay. So then we have to continue. Normally, well, on the other problem, we had something out in front of those parentheses that we had to distribute. Here, really all we have out to distribute is a 1, which isn't going to change anything. So really, I can just take away those parentheses. I don't really need them there. If all I'm distributing is a 1, those parentheses don't really mean a whole lot. Okay, so now we're on that step 3. Now we're ready to solve. First thing we do when we solve is combine like terms. We can take the negative 6x plus 3x. What would that give us? A negative 3x minus 1 equals 5. Jay Sean, what would I do next? We got negative 3x plus 1 equals 5, and I'm trying to get x alone.
Oh, you want x alone?
Yep. Add what? What should I add?
Add 2 to x. Oh, you trying to get... What are you trying to get by itself?
We're trying to get this x by itself. Get that x by itself. What's the first thing I need to do? Not deal with the negative 3, but I need to deal with this negative 1.
Oh, add 1.
Good. Add 1 to both sides. So negative 3x equals 6. Ellie, what should I do next?
Divide by negative 3.
Good. Now we're ready to divide. So x is equal to...
2.
Close.
Negative 2.
Negative 2. All right, do we have questions on finding the x? Okay, now we're on, I think it's step 4. Now we have to substitute this x value that we just found back into one of the equations to get y. So I'm going to erase what I wrote up here. Also going to switch colors for a minute. So now that we found that, we're going to take that x number and plug it back in to the x in that top equation where y is by itself. Really, you could plug it into either equation, but if y is already solved for here, then it's going to be easier to use this top equation. So we have y equals 3 times negative 2 minus 1. Solving this should be straightforward. We just do order of operations. 3 times negative 2. Anybody? Negative 6. Negative 6 minus 1 is negative 7. Step 5 on that chart said that we still have to write our answer as an ordered pair. So that means parentheses x comma y. My x was negative 2 and my y was negative 7. That's my answer. So just like with the graphing, even if you do all this work here and all this work over here, you still need to write your answer as an ordered pair. All right, on example 2. Which one of the equations is already solved for a variable? The top or the bottom? The bottom. The bottom equation already has y by itself. So on this problem, we're going to be taking the expression 3x plus 20 and plugging it in for the y in the top equation. So this time I will rewrite the top equation, negative 8x minus, for the y and put in a big blank, equals 24. Inside that big set of parentheses, that blank that I left for y, I'm going to put the 3x plus 20. That can replace y because y is equal to it. Now this one's a little bit different from the last one. We cannot just drop the parentheses because we have a negative or a minus sign out in front of them. So I have to distribute a negative 1. All right, so when I do that, I have negative 8x minus 3x minus 20. If we distribute in a negative, it's going to flip our signs around. Questions about that step? Okay, we're ready to combine like terms. Yes. Which one? This one out in front? This one will not change because it's not getting distributed to. That's a good question. So we're only distributing to what's in those parentheses. So those are the only signs that flip. It's a good point. Any other questions before we keep going? Okay. If we combine a negative 8x minus 3x, what do we get? Keon? Positive or negative? If they both started out negative, you lost 8, you lost 3 more. That's going to give you a negative 11x. Once we get to this point, I am trusting that you all remember your first semester skills well enough to keep this going. Deja, what would you do next to get x by itself? Wonderful. We add 20 to both sides. We have negative 11x equals, wonderful, 44. Keon, what would you do next? Good. Divide by negative 11. So x equals negative 4. All right, so now we have to go back and find y. So I'm going to take this x equals negative 4, and I'm going to plug it in to the other equation. So I take it and plug it into x in the other equation. That means I've got y equals 3 times negative 4 plus 20. This should be the easiest part because all we have to do is our order of operations. What's 3 times negative 4? Negative 12. Negative 12 plus 20 is 8. All right, and then somewhere we've got to write our answer as an ordered pair. I'm going to do it on the left here. Well, it's my x coordinate and my y coordinate. Beautiful. All right, let's keep it rolling on number 3. Which equation is already solved for us? The bottom one. Okay, so that's nice. The bottom one's already solved. That gets our first step checked off the list. So now we're on to a substitute step. We are going to substitute what into the top equation? What's getting substituted? Ellie?
Y equals negative 2x minus 8.
Okay, so the negative 2x minus 8 is going to get substituted in for y. Okay, that's what it equaled. So the negative 2x minus 8 is going into the y. So let's write that out. 4x plus 3, leave yourself some parentheses, equals negative 24. In those parentheses is going the negative 2x minus 8. Questions about the substitution step? I think that's the hardest step to get used to. The rest of it technically is all stuff we've done before. Solving for a variable, substituting it back in. Those are things we've done before. We have not substituted in a variable expression for another variable before. That's really the only new thing here. But if we're okay with it, we'll keep going. Can anybody tell me what to do next? Can distribute what? Good. If you've got a number in front of those parentheses, it has to get distributed in. The 4x that's out in front is just going to stay 4x for now. Houston, what do I get when I distribute that 3 in? What do I get when I distribute the 3? So what's 3 times negative 2x? Negative 6x. And what is 3 times negative 8? Negative 24. All right, we're ready to keep on going. Jaquan, what happens next? Okay, so what do I get when I take 4x minus 6x? Beautiful. Negative 2x minus 24 equals negative 24. Jamal Dixon, what happens next? Wonderful. These steps should feel very comfortable. We have solved equations for a long time. Oh, I guess I just gave that away. If you have a positive and negative of the same thing, you get 0. All right, last step to get x by itself, Kyan. Divide both sides by negative 2. So what does x equal? Anybody? 0. X equals 0. 0 divided by anything equals 0. All right, we are halfway done. We have the x coordinate. Now we still need the y coordinate. So we are going to take this 0 for x, take it all the way back over, and plug it into x in that bottom equation. Technically, you could plug it into either equation for x. It wouldn't really matter, but it'll be easier to do the bottom one because y is by itself. Jakeem, what's negative 2 times 0? Wonderful. Deshaun, what is 0 minus 8? 0 minus 8? Negative 8. Very good. And then finally we have to write our answer as an ordered pair. X comma y. What am I putting in for my x? 0, and my y? Negative 8. There's my answer. Questions on number 3. Nothing? Nothing? All right. Bring back number 4. All right, I want you guys to give number 4 a try on your own. And if you get through number 4, you can try number 5 and so on. Give these a try on your own. If you get to an answer and you would like to discuss with someone sitting near you, that's fine. And we'll talk about it in just a few minutes. So that first substitution step, we are going to rewrite the top equation. So 2x plus, instead of a y, I put a blank. What's going in that big blank? Natalie? Good. Negative 2x plus 8 with this expression from that bottom equation that y is equal to. So on this one, we're distributing a negative 1, which we've talked about how that doesn't really change anything, so we can drop those parentheses. So we drop the parentheses, and then we combine like terms. If you have 2x plus a negative 2x, what does that give you? 0. So you can write it as 0x, but 0 times x is really just 0. Okay, so these just cancel each other out totally. They are gone. We are left with 8 equals 8. Okay. We can't actually solve for a single value of x. If they cancel each other out totally, they're completely gone, you're not going to be able to solve for a single value of x. So now this is going to turn into a special case. Does 8 equal 8? Yes. If you end up with a true statement when one of your variables goes away completely, then your answer is infinitely many solutions. That only happens if a variable goes away completely. So the x's totally cancel each other out. And we ended up with a true statement, so there are infinitely many solutions. Questions about that one? Okay, if you were to end up with a false statement, so just as a example, like off to the side, if we had 2x plus negative 2x plus 7 equals 8, and those x's went away, and we ended up with 7 equals 8, is that true? No, 7 does not equal 8. So what do you think the answer is if you get a false statement? No solution. Okay, so if the variable totally goes away and it's a true statement that's left, there are infinitely many solutions. If it's a false statement, there are no solutions. Okay, so those are the special cases and what they look like here. When we graphed them, infinitely many meant they were the same exact line. No solution meant that the lines were nobody remembers. If there was no solution on the graphing, the lines were parallel. Very good. Somebody remembered. Okay. Let's see what example 5 holds for us. I think we've got time to get through one more example today. Which equation's already solved? The bottom. So I'm going to rewrite the top one, negative 12x minus 2. Instead of putting a y, I'm going to put a big blank, equals negative 1. What's going in my big blank? Keon? Negative 6x minus 6. All right, we have to solve it. So the first thing we're going to do is distribute the negative 2. We have to treat it like a negative 2. So negative 12x. Who can tell me what we get when we distribute? Ryan?
Negative 12. No, 12x and minus 12. Oh, wait.
So we've got negative times a negative is a positive 12x, and a negative 2 times a negative 6 is a positive 12 again. All right? So we distributed into the parentheses. When we combine like terms, what happens? Jamal? We add the negative 12x with the positive 12x. So what happens with those? They cancel out. A negative and a positive of the same exact thing cancels out. So we are left with 12 equals negative 1. What do we think about that? Is that true or false? It's false, which means our answer is no solution. Okay, we are going to have to save the rest of those examples for tomorrow. So we will end the notes there.